Welcome to week 6 of our lesson, which is square root. After going through this module, you are expected to describe principal roots and tell us whether they are rational or irrational. Determine between what two integers the square root of a number is and plot irrational numbers on the number line. Recall that a rational number is expressed as a fraction or decimal. Every terminating or non-terminating repeating decimal represents a rational number. A square root of a number is a number when multiplied to itself will give you the original number. For example, the square root of 9 are positive 3 and negative 3 because when positive 3 and negative 3 are multiplied to themselves, they are equal to 9. If the square root of a number is non-terminating, non-repeating decimal, we say that it is an irrational number. Every positive number has two square roots. One is positive and the other is negative. The principal square root is the positive square root of the given number or radicand. The principal root is rational if the radicand is a perfect square. If not, then the principal square root is irrational. 0 has only one square root, which is 0. In addition, negative numbers do not have real square roots. Their square roots are called imaginary numbers, which are tackled in a higher branch of mathematics. Square roots are the numbers that, when multiplied by themselves, equal to the number under the square root sign, the radicand. If the principal square root is irrational, the best you can do is to give an estimate of its value. I have here the list of perfect squares. Square root of 1 is equal to positive or negative 1. Square root of 4 is equal to positive or negative 2. Square root of 9 is equal to positive or negative 3. Square root of 16 is equal to positive or negative 4. Square root of 25 is equal to positive or negative 5. Square root of 36 is equal to positive or negative 6. Square root of 49 is equal to positive or negative 7. Square root of 64 is equal to positive or negative 8. Square root of 81 is equal to positive or negative 9. Square root of 100 is equal to positive or negative 10. Square root of 121 is equal to positive or negative 11. Square root of 144 is equal to positive or negative 12. Square root of 169 is equal to positive or negative 13. Square root of 196 is equal to positive or negative 14. Square root of 225 is equal to positive or negative 15. Square root of 256 is equal to positive or negative 16. Square root of 289 is equal to positive or negative 17. Square root of 324 is equal to positive or negative 18. Square root of 361 is equal to positive or negative 19. Square root of 400 is equal to positive or negative 20. Square root of 441 is equal to positive or negative 221. Square root of 484 is equal to positive or negative 22. Square root of 529 is equal to positive or negative 23. Square root of 576 is equal to positive or negative 24. Square root of 625 is equal to positive or negative 25. Square root of 676 is equal to positive or negative 26. Square root of 729 is equal to positive or negative 27. Square root of 784 is equal to positive or negative 28. Square root of 841 is equal to positive or negative 29. And square root of 900 is equal to positive or negative 30. Let's have illustrative example number 1. Find the principal root of square root of 49. Solution. Square root of 49 is equal to positive or negative 7. This means that the square root of 49 is either 7 or negative 7 because 7 times 7 is equal to 49 and negative 7 times negative 7 is equal to 49. Thus, square root of 49 has a principal square root of 7 and it is rational. Illustrative example number 2. Determine whether the principal root of the square root of 17 is rational or irrational. Solution. Square root of 17 is equal to positive or negative square root of 17. The radicand 17 is not a perfect square. If the radicand is not a perfect square, then the principal square root is irrational. When a number is irrational, estimating square roots is a valuable tool. We can approximate the square root of a number by looking for two consecutive integers between which the square root lies. Irrational numbers never terminate nor repeat. The decimal form of an irrational number is always an estimate of its value. Illustrative example number 3. Between which two consecutive integers does square root of 6 lie? Solution. 6 lies between the consecutive perfect squares 4 and 9. We all know that 6 is greater than 4 but less than 9. So if we're going to write it in square root form, so we have square root of 6 is greater than square root of 4 but less than square root of 9. So we all know that square root of 4 is equal to 2 and square root of 9 is equal to 3. Therefore, square root of 6 is greater than 2 but less than 3. Thus, square root of 6 lies between 2 and 3. Illustrative example number 4. Square root of 75 lies between what integers? Solution. 75 lies between the consecutive perfect squares 64 and 81. So if we're going to write it, 75 is greater than 64 but less than 81. So if we're going to use the square root form, so square root of 75 is greater than the square root of 64 but less than the square root of 81. We all know that the square root of 64 is equal to 8 and the square root of 81 is equal to 9. Therefore, the square root of 75 is greater than 8 but less than 9. Thus, the square root of 75 is a decimal number greater than 8 but less than 9. Illustrative example number 5. Estimate the square root of 10 to the nearest hundredth. Solution. The principal root of the square root of 10 is between 3 and 4. By estimation, 3.1 squared or 3.1 times 3.1 is equal to 9.61 and 3.2 squared or 3.2 times 3.2 is equal to 10.24. The square root of 10 must lie between 3.1 and 3.2. Continue the estimation to the hundredth place. 3.15 squared is equal to 9.9225. 3.16 squared is equal to 9.9856. 3.17 squared is equal to 10.0489. 10 is closer to 9.9856. Therefore, by estimation, square root of 10 is equal to 3.16. Illustrative example number 6. Estimate the square root of 45 to the nearest hundredth. Solution. The principal root of square root of 45 is between 6 and 7. It is closer to 7. By estimation, 6.7 squared is equal to 44.89. 6.8 squared is equal to 46.24. The square root of 45 must lie between 6.7 and 6.8. Continue the estimation to the hundredth place. 6.71 squared is equal to 45.0241. 6.72 squared is equal to 45.1584. 45 is closer to 45.0241. Therefore, by estimation, square root of 45 is equal to 6.71. Irrational numbers are found on a number line by approximation. We can plot an irrational number on a number line using its estimated value. Illustrative example number 6. Plot the following irrational numbers on the number line: square root of 3, square root of 23, and square root of 48. Solution. Using the estimates, square root of 3 is closer to 2. Square root of 23 is closer to 5. Square root of 48 is closer to 7. By approximation, the given irrational numbers are plotted on the number line below. Square root of 3 is equal to 1.73, square root of 23 is equal to 4.80, and square root of 48 is equal to 6.93. Therefore, square root of 3, which is equal to 1.73, is closer to 2. Square root of 23 is equal to 4.80. So 4.80 is closer to 5. And square root of 48, which is equal to 6.93, is closer to 7. Therefore, square root of 48 is closer to 7. Plot the following points on the number line. Point A is equal to square root of 7. Square root of 7 is closer to 3. Point B is equal to square root of 38. Square root of 38 is closer to 6. Point C is equal to square root of 43. Square root of 43 is closer to 7. Point D is equal to square root of 92. Square root of 92 is closer to 9. And point E, which is equal to square root of 105, is closer to 10. Let's proceed on answering learning task number 1. Write S if the square root of the number is rational and I if irrational. Letter B. Between what two integers the square root of the numbers can be found? Moving on to learning task number 2. A. Tell whether each of the following is a rational or irrational. If it is rational, give the principal root. B. Between which two consecutive integers does the square root lie? C. Estimate the square root to the nearest hundredth. D. Plot the following irrational numbers in the given number line. Now, let's have learning task number 3. Read the problem carefully, then answer the questions that follow.